Hey everyone, and a very warm welcome to this explainer. I'm absolutely thrilled to have you here today. Get comfortable because we're about to zoom way down into the microscopic world. We're going to discover some hidden secrets of the universe, and we'll take it step by step. So put on your science hats and let's jump right in. Okay, let's start with a really big question. Have you ever wondered what you're actually made of? Or, what your desk, your pet dog, or even a glass of water is made of? Well, think of absolutely everything around us as giant, amazing structures. Now imagine if you could zoom in so closely that you could see they're all built out of tiny, invisible Lego blocks. That's right, the whole universe is basically just one giant Lego set.
Which brings us to our first section. Meet the tiny atom.
So, what exactly is an atom? The strict definition is that it's the smallest particle of an element which takes part in a chemical reaction. But let's make this a little easier to picture. Imagine you have a shiny piece of gold. If you start grinding it down, it breaks into smaller and smaller pieces. If you keep going, smaller and smaller, you'll eventually reach the absolute tiniest block of gold that you simply cannot break anymore. That ultimate, unbreakable, tiny block? Well, that's the atom.
Think about how our toys work. You know how standard Lego blocks really can't be broken down into smaller pieces? You just use them to build bigger things. Atoms work exactly the same way. They are the basic building pieces of all matter. Literally every single thing in your room right now is just a giant collection of these ultimate Lego blocks.
All right, moving on to section 2, friendship of molecules.
So, we have these tiny, single atoms, but atoms don't always like to be alone. Let's zoom out just a tiny bit and see what happens when these lonely atoms decide to make friends. When atoms want some company, they basically hold hands and form a little friendship group. In chemistry, we call this friendship group a molecule. A molecule is simply the smallest unit of a pure substance which always exists independently. That means once these atoms hold hands and become a molecule, they're strong enough to survive all on their own out there in the big wide world.
But not all friendship groups look the same. Sometimes atoms only want to hold hands with their exact identical twins. For example, two oxygen atoms holding hands make an O2 molecule. That's a molecule made of the exact same kind of atoms. But other times, atoms like to mix it up and form a group of different friends. Look at water, or H2O. That's one oxygen atom holding hands with two little hydrogen atoms. So that's a molecule made of different kinds of atoms. Now, since we're talking about these friendship groups, scientists actually have a special word for counting how many friends are in the group. That word is atomicity. It simply means the number of atoms present in one single molecule. You're literally just counting how many little atoms are holding hands. Let's break down the different types of molecules based on their size. Some atoms are very independent and like to be solo. We call them monoatomic, like helium. Mono means one. Then we have diatomic molecules, where two atoms hang out in a pair, like the oxygen we breathe. Di means two. If three friends hold hands, it's a triatomic trio, like ozone. And if four or more atoms decide to form a large happy squad, we call that polyatomic, like phosphorus or sulfur. Poly just means many. Next up is section 3, reading chemical formulae. You guys are doing fantastic so far. Now, we need to know how to write down the recipe for these molecules, so chemists all over the world can understand them. A chemical formula is basically a recipe card for a molecule. Just like a baking recipe tells you that you need 2 eggs and 1 cup of flour to make a cake, a chemical formula tells you exactly which ingredients, meaning which atoms, and exactly how many of them are needed to build that specific molecule. The most important part is knowing how to read the numbers in this recipe. Let's look at the difference between a big number in front and a tiny number hanging at the bottom. If you see a big number in front, like the 2 in 2C, that means you have 2 separate, single atoms that are not holding hands. They're just standing next to each other. But if you see a small number written below, like the little 2 in H2, that means those 2 hydrogen atoms are permanently stuck together, holding hands in one friendship group. Big number means separate. Small number means stuck together. Pretty easy, right?
All right, section 4, journey inside the atom.
Take a deep breath, because things are about to get really exciting. We're going to shrink down even smaller and take a journey directly inside the atom itself. What could possibly be hiding inside our tiny Lego block? Well, for a long time, people thought atoms were just solid little balls. But guess what? They aren't solid at all. There's a whole busy little world hiding inside every single atom. Let's zoom in.
Right in the very middle of the atom, there's a tiny, heavy control room called the nucleus. To picture just how incredibly small this nucleus is, imagine the atom is the size of a massive, giant cricket stadium. If the atom is the whole stadium, the nucleus would be just a tiny little cricket ball sitting directly in the middle of the pitch. That is how much empty space is inside an atom.
Now let's meet the cute little characters that live inside the atom. Inside that central control room, the nucleus, we have two heavy friends. First, the proton, who always has a happy, positive electrical charge of +1, and the neutron, who is completely neutral with no charge at all. They both weigh 1 atomic mass unit. But zooming around outside the nucleus is our third friend, the electron. The electron is incredibly tiny, practically weightless, and carries a negative charge of -1.
Now here's a really fun puzzle. If atoms are full of these positive protons and negative electrons, why doesn't everything we touch zap us with electricity? Why is your desk or your notebook totally safe to touch?
Well, think of it like a perfectly balanced seesaw in a playground. In any normal atom, the number of happy, positive protons inside the nucleus is exactly equal to the number of negative electrons zooming around outside. So if you have 6 positive protons, you also have 6 negative electrons. The pluses and minuses balance each other out perfectly, meaning the whole atom stays completely neutral, so no zapping.
But those tiny, negative electrons don't just fly around randomly. They actually move in very neat, organized circular tracks called shells or orbits. It's much like planets moving around the sun. Think of these shells like rows of seats on a school bus. The first row of seats, closest to the nucleus, is very small. It can only hold a maximum of 2 electron students. The second row is a bit bigger and can hold up to 8 electrons, and the third row can hold up to 18 electrons, and they always fill up the seats closest to the front first.
And finally, Section 5, Recap and Mini Quiz.
Wow, we have covered some amazing ground today. You all have officially gained some serious chemistry superpowers. Let's do a really quick recap to make sure these ideas are totally locked in, and then we'll have a fun mini quiz. Let's go through this together nice and slowly. Remember, atoms are our ultimate smallest Lego building blocks. When those atoms hold hands and make a friendship group, they become molecules. Chemical formula are just the recipe cards telling us which atoms are in the group. Inside the atom, we have the tiny, heavy control room called the nucleus, which is home to the protons and neutrons. And finally, those tiny negative electrons zoom around the outside in organized tracks called shells.
Okay, are you ready for your mini quiz? Shout the answer at the screen when you know it. What do we call the tiny, heavy control room right at the center of the atom? Did you guess it? That's right, it's the nucleus. Fantastic job.
Let's try just one more. If the formula for ozone is O3, meaning it has that little number 3 at the bottom, what is its atomicity? Yes, it has 3 atoms holding hands, which means its atomicity is 3, making it a triatomic molecule. You guys are doing so incredibly well. You have completely mastered the basics of atoms and molecules today. I am so proud of you. But here's a little secret before we go. Sometimes those atoms on the school bus want to trade their electron seatmates with other atoms. What happens when they start giving away or stealing electrons to make new chemical bonds? Well, that's a totally fascinating story about something called valency, and we're going to explore all of that in part 2 of this explainer. Until then, keep wondering, keep learning, and I'll see you next time.